Welcome to the first video in my 3D design series, where I'll be designing a series of items using 3D design software, which can then be printed out. Initially, my videos looked at the EasyThreed K9 3D printer, which is easy to set up and easy to use. And I wanted to design something to fit in the 10 by 10 by 10 centimeter print volume. I decided to make an improved clip to fit this carrier into the stand, and in the initial model I used things that came to hand, and I happened to have these pipe clips which would fit onto 15mm in hand, so I just used those. But now I'd like to improve on that by making an actual clip which I designed myself, and we can then print it out on the EasyThreed K9 printer, so we can show that the K9 printer is capable of producing actual usable 3D printed parts which can be used in various applications. So I'm going to design a clip which closes with an M3 screw and a butterfly nut. And I thought it would be a useful project to start with for a 3D design, because it's a fairly simple project. And what I'll do is I'll run through making it, how I thought about making it, and what I did in the 3D design software which I'm going to be using, which is called Design Spark Mechanical. And Design Spark Mechanical usefully has a free version called the Explorer version, which is what I've been using and what I use to design all of my things that I have designed in 3 dimensions. I find it's very easy to learn, and it's a very useful software. I'll break now and I'll go to Design Spark Mechanical, and hopefully you can follow along what I'm doing in the project. Right, so you want to, in order to get Design Spark Mechanical, you have to do a search for Design Spark Mechanical in Google, and then go to this link, click on that, and then come to this, and it just immediately, when you get there, you can see the download link here. Although it looks at a lot at electrical circuit boards and things like that, and other things in the electrical sphere, you can use it perfectly well for other designs. Anything you like, of course, you can design here. And I've already done that in the past. Just to tell you, of course, that it's only for Windows at the moment. I'm not sure whether they're going to, or thinking about releasing other versions. So you can see the plans here. This is in GB pounds, of course, because I'm here in the UK, and I suppose wherever you are it will appear in your currency of choice. You can see here that the Explorer version is free, always, no hidden fees. You do have to subscribe to it, as you would maybe with a paid, but it doesn't cost you anything. These ones here, of course, you can see are paid, but it's a very modest kind of charge that you'll be paying here. If if that's appealing to you, it might be things which you want to do. Like, as we can see with the free version, there's only certain things which you can do with it there. If you want to import an STL, you can't do this with the Explorer version. Some people, what they'll do is to import a model that someone's already made, and then kind of change it to how they want. Maybe if they want larger holes for fittings, or things in a certain different way, they'll import the STL and then change it. And one of the excellent things about Design Spark Mechanical is it makes it really, really easy to import STLs and actually change them. Before it was actually, this subscription was actually changed, you could actually import STLs, but recently, I think in the last year or so, they took that feature out and made it a paid feature. So that's I don't use it very often, but lots of people do. I tend to feel that actually when I create something, it's just easier to design it myself with the specifications that I want, rather than something else that someone else has made. Very often the STLs have a great number of complexity in them, and it does make it hard for the software when there's so much complexity in the actual model that you have to import. I found that with Design Spark Mechanical doesn't seem to suffer that much from that kind of thing. Other softwares, when you import STLs, can get very slow, but Design Spark, as I say, Design Spark Mechanical doesn't seem to suffer from that particular issue. And there's other things like import step files and DWD and GXF formats and so on, which you can do with the paid versions as well. So anyway, we'll crack on with this. I've shown you basically where you need to go to get it, and I've said that it's a Windows only software for the time being. Okay, so now we'll crack on with actually going in to design the part which I talked about, which was the clamp for the 15mm tube. So I'll just close this down now and go to my own installation. Yeah, so as you can see, I've got it in my dock down at the bottom here, and I'll just click on that and open it, and it's already opened. So what I normally do here to go to start a design is to go to File, which is at the top left corner, and just click on that, a single click, and then just New, and then Design. That comes, you can now see in 3 dimensions from an angle the plane which you'll do all your sketching on. What I normally now do is just come up to the top left hand corner again, so that you can make this into a kind of a flat screen, so that you can draw your sketches on it. So I'll just go to Plan View, that's in the top left hand corner again. Just click on that, and it'll then bring it into, so it's right in front of you, so you can do your sketches on it. Now you can see here there's different tools which you can use. This is mostly about how you view the model or the sketch, and these are tools that help you sketch, and these are to help you select different parts of the model, and there's various other things here. I won't go through them all because it's not any point at the moment. It's best to go through them as you need them, really. So really what we want to do first of all is to create a hole, which I'm going to do with this tool. I'm going to create it anywhere. As you can see, the actual sketch plane here is actually clicking to these points, and they're a millimetre as far as I understand it, each of these little units. It's really immensely clever the way it deals with it, but you're automatically starting on a whole unit instead of starting in a kind of a half a unit or something. So I'm just going to randomly choose this point on the sketch plane and just click and then drag the circle. Now we said that we're starting at 15mm. What I normally do with anything like this is if I want something to fit over something else, like you could start with 15mm, but a whole 15mm in size won't fit over a rod that's 15mm in diameter, because of course it's the same size. It needs to be slightly larger. So what I always do is you can type into this little box here. So I'm going to type in 15.25, and I always leave an additional 0.25. This is for 3D printed objects. It might be different with machining. I'm sure it probably is. The tolerances will be different, but I usually say 15.25. I always add 0.25 of a millimetre onto every size I do if I want something to fit over something else. So we're going to start with that, and we're going to press enter now. So we've seen we've now got a circle, and it's 15.5. It's selectable. You can see when the cursor moves over it, it highlights it. Now I made the hole so that it fits over the pipe. So what we need to do is really make another circle, and that will then give us a thickness. So I'm going to say 15 to give us a reasonable thickness. I always think that for anything like this, probably 5mm is a good idea. So say 26mm for this, because it gives us a good thickness on the sides here, and hopefully that should be strong enough for what we're planning to do with it. Obviously we've got to make a clamp, we've got to make a closure for this. So what I'm going to do now is just to use the square tool here and choose a point here. Now I'm going to make a square. It's going to be, as you can see how the cleverness of this system is working in our favour. That's 12mm from top to bottom, and it's symmetrical over the centre of the circle. I'm just going to choose this as a random point now. This is basically, when we produce this in 3 dimensions, it will create a platform for us to put the washer on when we tighten down the clamp. So this is what I'm making now. It's in 2 dimensions. Soon we'll pull it into 3 dimensions, so you'll be able to see how you do it. It's very easy. You start with a 2-dimensional sketch, and you basically do as much as you can. The way I like to do it is I always like to do as much as I can on the first sketch, so you need to think about it ahead of time. Most often I don't bother to make any written plans ahead of time. I just do it on the fly, and it seems to work. I mean, if you're the kind of person that likes to spend a lot of time thinking about things, you can do that, you know, fair enough. What I'm going to do is, I'm going to go to the line tool again up here on the top, and then choose that. Sometimes if I want to measure something, I'll just use the line tool, because it gives you a quick measure of things, and it snaps into the points, as you can see. So it now says that distance from the edge of the circle to the end of the clamp part is now 16.47 millimeters. I think that's pretty adequate, so I'm going to leave that like that. If you want to get out of that tool, you just press the escape key. What I want to do is also, when clamping 2 things together, you want to have a bit of ability to clamp. So I need to cut a hole in through this to the outside, so that when the 2 sides clamp down, we've got our 0.25 millimeters that will allow our clip to fit over the top of our pipe. But also, when we're clamping it, we want to give ourselves a bit of a gap to clamp it, so that when you tighten the clamp, it's got something to tighten on. So I think I'm going to give that 4 millimeters. I'm going to, we've got our center point here. Another thing, when you hover over a line, if you're in the middle, it'll come up with a little triangle, which will enable you to see that it's the center of the line. Oops, there we are. Just press the escape button, and it gets out of the tool. So you can see there that there's a little green triangle that indicates the center of the line, and again, that's very useful. It saves you having to constantly measure things. What I normally do is, you can see there that's 2 millimeters exactly on the spot of that line. There's 2 millimeters up from that, and if I want a gap of 4 millimeters, then that's where to start. So I'm probably going to try that square again. I go up onto that line 2 millimeters from the center line, and then click there, and then drag it down. So you can see that it's dimensioning the cut automatically there at 4 millimeters, which is what we wanted. I'm going to take that out to the edge. So now we've got our cut. I don't know whether 4 millimeters is too much, but I'm going to just go with it, because you do need something to clamp it down on. These things have a habit of coming together as well on the tips when you close them down. So I think we do need to have a reasonable, decent ability to tighten it down, and 4 millimeters I think will probably be more than enough. So I'm just going to stop that, and then, so now what is good, there's another good tool here which enables you to get rid of lines that you don't need. So some of these lines we don't need anymore. So this is where it says trim away. So I'm just going to click on that and come down and select lines that we don't need. We don't need this line, and any lines inside aren't needed, so I'll get rid of those as well. This one, we don't need that one. That one there we don't need. This little one here, this little one, these ones aren't needed. This one isn't needed. It's just cleaning it up before you create it in 3 dimensions. So now we've got our basic shape here. Now I'm going to pull it into 3 dimensions. So what you need to do here is to use the pull tool, which is here, and then go over the shape. This means that I've done something wrong somewhere. Oh, I know what it is. Let's just go back to that trim away, and see if we can get rid of that line at the end there. I don't know if we can. Zoom in. It's not doing that. I think we need to go back to this sketch again. So I'm going to go back here to the sketch again by just using the back button. And then I'm going to go to the trim tool, it's there ready. And I'll just see if I can get rid of this line here. Doesn't look like I can. It wants to choose the whole of that line. I do there. What I might do is just draw those lines in again between that, so we can close that off to make it up. There we are. And then we do the same with this one. And as you can see, it's clicking. It's snap to grid. It's snapping. That's what I would say. It's snapping to the points. And again, you can zoom in. I'm using the trackpad. I'm doing it automatically because I'm used to using the software. I'm just dragging 2 fingers up and down on the trackpad to zoom in and out. I think it's done it now. So what I'm going to do is to go back to the pool tool again. There we are. Now you can see that it's fine, it's worked, and we've got rid of this bit in the middle by trimming away that line. So now I'm just going to select that. It's already, the cursor is hovering over it, so it's turned yellow, which means you can select it. So I'm going to select it. Now it's turned orange, which means it's selected. What you can do is go across to the spin tool across here up on the top left, click on that, and now if you click on the mouse, and I'm using a trackpad of course, if you click on the trackpad and move with a single finger, you can move it into into 3 dimensions. Now you can see it in 3 dimensions. You can see the pull tool here, which is this little yellow arrow, and I'll just click on the pull tool again, and then you can it sort of activates the yellow arrow, so now you can pull it out into 3 dimensions. And normally with anything like this, which is where I'm going to have to put a hole in, because we're going to have to put a hole in there to create a point for the bolt to go through, I'm normally looking at 15 millimeters for that, so I'm going to make this 15 millimeters thick. Again, you can type into that little box and you can make it, and then press the enter key and it will make it whatever you've chosen for it. So now we've got a shape here that's 15 millimeters. It's our clamp, and I'm going to use the spin tool again to move it around so you can have a look around it. I'm going to choose the select tool. We've got our shape. I'm going to go back to the spin tool here. Yeah, so really what we want to do, I want to put a hole in the middle of this clamping piece on the left side. So what I'm going to do is to select the top face of that platform there and click it. And then I'm going to just, this is the way I like to do it. I'm sure there's probably a quicker way of doing it, but the way I like to do it, if I want to put a hole in the center of anything, I'll choose the line tool, and then you go back into the sketch mode automatically and just put a line from corner to corner. That will give you the exact middle, of course. I'll just get out of that by pressing the escape button and go to the opposite corner. Another good thing on the side is the way when you go into the sketch mode on this particular software, it automatically truncates the model down, so it actually makes a section here, so you can see right through it in the section of the sketch that you're actually working on, and I think that's a pretty useful thing really. Now I want to make a hole here, and I'm going to go for the circle tool again, and then I'm going to choose that intersection of 2 lines. And normally what I do with all of my fixings for 3 millimeters, I go for 4 millimeters for the hole, so I'm just going to choose 4 millimeters for that. And then again you can see that it's dimensioned it at 4 millimeters, and what I can again do is to remove the extraneous lines by going to the trim tool, and that one, that one, that one, and also these ones here. It's always a good idea to remove any unnecessary lines. Later when you come on, the model's got a bit more complex. If you have lines in places where they aren't needed, it can sometimes cause a problem. So it's always a good idea to do that. What I want to do again now is to spin the model around. So I'll go to the spin tool and then just spin it round like that. And I'm going to go to the pull tool again. Now you've gone, so you should be able to select that. Here we are, we can select it. So I'm just going to select that. It's turned orange to see it's selected, and just use this to pull the hole right through to the other side. You can see that it's gone right through. Generally when I do that, if I drill a hole through something, I'll just gently use the pull tool to pull it all the way through to the other side and not worry too much about how deep it is, as long as it goes all the way through. So we've got our flange now, and we've got our hole. There's not much left to do actually. You can see how simple it is to use and how powerful, what a wonderful piece of software this is. Alright, what I could do is put a receptacle for the bolt head, like a, I'm just going to rotate it around, so just going to again measure. Actually, if you go to the select tool there, you can then click on any line there, and it will give you the length of the line, which I think is down here on the bottom right hand side at 3 millimeters. Let's just verify that. No, it doesn't. I thought it did. I'm a bit rusty in this. It's some time since I've used it. Again, if you've got a sketch, because you can see there's a sketch plane selected here. It's gone on the end of the... what you can do is, if you go into plan view, you can bring it up like that, and it'll rotate the model automatically for you. Now we want to just check how long that line is. This is what I do. It's a very rough way to do it. Just use the line tool. So we now know it's 4 millimeters. Normally, if I'm having two surfaces, I like to have 5 millimeters, just for a rough rule of thumb. What we could do is make it into 5 millimeters. Let's just escape that and use the spin tool again to rotate the model. And then I'm going to select, no I'm not, you need to go into, there's various different modes here. As you can see, there's a sketch mode here, and there's 3-dimensional mode, and there's another one in the middle. I'm not quite sure what that is. Let's just go into the 3-dimensional mode again. I think we need to do that to select. So I'm just going to select this side of the model, and then I'm going to go to the sketch tool, or I could go to the line tool. All I want to do is to add a little thickness to this. I can't simply extrude it, because then it might be worth trying that. Spin the model again and come down here and just see what happens if I do that. I'm just going to select this surface and see what happens if we pull it. I'm going to pull it by 1 millimeter and see what happens. And see if it rides up. Oh yes, it does, look. That's the useful thing. It rides up there, so that means that you don't have to do that. Automatically rides up the surface it's attached to, making it larger at the same time. So you're going to have 1 millimeter for that to make it into 5 millimeters. I'm going to come round and do it on the other side to make it symmetrical, using the spin tool. I'm just going to use the select to select this face, and I'm going to use the pull tool again. So you've got your little yellow arrow, and I'm going to pull that 1 millimeter as well. Yeah, so that's now 1 millimeter thicker, making it up to the magic figure of 5 millimeters that I like to use a lot. Okay, right, let's spin this around, have a look at it. It's a good idea to occasionally inspect it to see if you've got everything you want with it. Yeah. I have got some 3mm M3 bolts. And we know we've got 5 millimeters on one side, 5 millimeters on the other side, and a gap of 4 millimeters. That gives us a distance of 14 millimeters for our. It's a minimum distance. Well, it's not really the minimum distance, but it's a distance for our bolt to be. So we need to have a bit more than that. Got a little packet of M3 bolts that I keep for occasions such as this. You might be forced to
choose a size that I've got rather than choosing the size which works best. It might be a good idea to have a hex head on the other end of the thing to lock the rotation, so that when we put the nut on, it simply doesn't turn and turn and turn. Or you have to have something else on the other end of it to hold while you turn it. I don't think yeah, it might be that we're forced to use the size I've actually got rather than the size I can buy. I can always buy something larger, I suppose, but at the end of the day it's more economical to have something you've already got. What you could do is, if you had a longer one, you could lock two nuts together, back them together so that they lock. Now, another thing, guys, to get if you want to do this is a vernier caliper to measure things. You need to be able to measure things accurately, and a vernier caliper will help you do that. And they can be had for very little money these days. I'm going to recess it here. We know that the head is 2mm thick, so I'm going to make a recess for the head to fit into. It might be deeper than 2mm because it needs to sit in it, so it doesn't just pop out when it feels like it. So I think what I might do is try and make the head a bit deeper recessed. We've got 5mm to play with. I think that the spanner for M3 is 5.5 size. Yeah. What I'm going to do is, I'm not sure if I can use what I've already got, but at least I've got the dimensions of them. I'm going to put a hexagon there. So we've already got that highlighted. If we go into the sketch mode, that will bring us onto that plane there, so we can do a sketch on that plane. So I'm just going to use the spin. Actually, of course, we can use plan view. Just press plan view and it brings you up on that circle there. We've got our center point coming up, so what we need to do is to use the polygon tool in there, and we'll just drag that over, and it gives you a polygon automatically, which is going to be suitable for your so it's giving us 6mm there. I think I'm going to go with 5.5 because that's the size of the spanner and we know that, so I'm just going to type that in as 5.5. With a bit of luck, that should give us exactly the right size hole for our nut to sit into. And I'm just gonna, we've got that now and I'm happy with that, so I'm going to go to the pull tool again, and I'm going to just pull that down into the, I'm going to select that, and then I'm going to use the spin tool to rotate it so it's easier to see the shape being pulled. Go back to the pull tool and just recess that down. We know that the head of this nut is 2mm thick, so I think I'm going to go, we know we've got 5mm of thickness to work with. I think I'm going to go down 3mm with this. Then I'm just going to type in and then press the enter button to produce that. I'm going to go to select. You can see that there's a surface here which we probably don't need. As I said in the past, it might cause issues later. If you look in the top left hand side, you can see these entries here which show different elements of the model. This is the solid, which represents the yellow area, which is the clamp itself, and this is the surface here. It shows that there's a surface there. I'm just gonna, I don't know if we can just delete it or whether I might just right click on that to see if there's any options. You can see when you right click, a whole series of options come up. I don't know whether I can just delete it without causing problems. Let's just try. Yeah, it's gone, and it's gone in the tree there that shows the structure, so that's good. As I said before, it's a good idea to try and get rid of any things that you don't need, because they might cause problems for you later. Let's just spin this round again and have another look. So now we've got our recess for our bolt. We know that I've recessed it 3mm, so we had a total of 5mm to start with. Now we've got 2mm left. That also helps us with the thickness, the length of the bolt as well, if we don't have enough. Because should have 2mm here plus 4 for the gap, and I need another 5. That's 6, 11, isn't it? So 2 for this, 4 for the gap, 6, and 5 on the other side. 6 and 5, 11mm. It's possible I can then use the bolt which I've actually got, so that should be enough to actually do this project. It needs to have some threads inside the nut, because otherwise it won't be enough to hold it. I might just tidy it up a bit by putting some chamfers on it and again we can do that with a pool tool. One of the good things about Design Spark Mechanical, you can see that how many things you can do with the pool tool. You can do lots of things here like scaling and all sorts, and it makes it very useful. There's also other options down here of different things you can do with it. What I'm going to do is to choose these lines here, or actually no, I'm going to choose these lines, and if you hold down the control button and click with the mouse or with the trackpad, you can select multiple lines at the same time. I'm going to just select these one after another. Now they're all selected, you can see that they've all turned yellow. I'm going to use the pull tool to pull them a bit, to create a fillet on them, just to round off the ends of these pieces, because clearly you don't need that material, it's not necessary, so there's no point in using our precious filament to create something which is not needed. So that's what I'm going to do with that, and I'm just going to go onto the select tool and then do the spin, and you can see around it a bit more. You can see that it's created that fillet on the edge of these things, and there's a lot of unnecessary material that won't be wasted now. I'm a little thinking that these corners here on the edge of the circle, or the edge of the tube, might bind against the tube when you close the clamp, and it might be an idea to chop some of that away. So again, I'll choose the pull tool, select the lines, these two lines. I'm not sure if I can select it from this angle. It looks like I might be able to. Just control and click there to select that one as well, and then move the cursor over the pull tool and then just pull it down a bit. I'm not going to go too far with this. I think I might just round them off a little bit, so showing the radius, I can't quite see it against the, it's like 1 point something other millimeters. What I might do is, you can see it now, I'm going to go for 1.5 just to keep it whole numbers, and there, just to round those corners off. Right, all this is really unnecessary. You could say it was done before, but I just thought it would be a good idea to save some material. I'm just going to go onto the spin tool again. I might just have to, I think maybe I just need to press enter. No, I think maybe just the select tool. Sometimes when you're doing this, I normally go back to the select tool after I've done an action. It might be that I'm missing something about the way that the software works, but it usually kind of fixes what I've done. So now I'm going to use the spin tool again just to have a look around it and see if I'm happy with the way it looks. I'm happy with this, these surfaces here, and I'm happy with the indent that I've made for the nut to go on the other end and to stop it spinning when you turn the wing nut. That looks nice to me. So basically that's now finished, and you can do is just go to File and save as. So you can see I've got a number of other things here already that I've done before. So I'm just going to choose my file name, and it has its own file format. You can see this RSDOCX file, and it's going to save that in my documents. So you can obviously create a separate folder if you want to, but I'm okay with this. So I'm just going to say 15mm pipe clamp. I'm just going to save that. What it might be a good idea to, I have the habit of doing lots of sketches and lots of designing things without actually saving the file, and obviously it's dangerous because if something would happen to the computer you'd lose it. So it's probably advisable to actually do this at several points through the construction of your model. What also could happen is that you could accidentally make some changes which you don't like, and if you have a previous version to go back to, that can sometimes help you out of a difficult situation. I'm just going to have a final look around. Just have a look at that. That looks nice to me. Right. So basically when you start a project, I just generally go to the sketch to start with. You know, when you enter the Design Spark Mechanical, it will automatically come up with a sketch plane, and all you have to do is put plan view, and then you can do your sketch. And when you've completed it, when you've done it as much as you can then use the pull tool to pull it into 3 dimensions. It's such a simple thing to use, but it's so powerful. You've made now something which didn't exist before, and now we can just simply put it on our 3D printer and print it out, and then we've got it. So that's just amazing, so powerful, and a very useful thing. The first file type we made was to actually save the 3D design, but now we have to go back and actually save it as an STL file so we can import it to our slicer. So again we have to do save as. And then when we look down here, this save as type, what we need to do is to change that to STL, and then it will come up with the same file name that we chose before. Let's do save. So it's come up with automatically with that 15mm pipe clamp. Let's save that. Now it's saved as an STL file, so we can import that into our slicing software. So I'm just going to go out of Design Spark Mechanical. So now I've opened up Cura, and I'm just going to import the model. As you can see, I've had a look at the model and just increased the size of the inner tube so that it goes over the pipe more easily to 16mm. So there's the original one that's 15.5 and the top one which is at 16mm. So I'm going to open that right in immediately, and it's going to zoom in a bit and get a better view of it. It's going to, yeah. So you can see it's got the little recess here for the nut to fit into, the M3 nut, and on the other side the 4mm gap, and the 4mm gap here, and the 16mm hole here which I just made slightly larger. I'm just going to check the print settings, and layer height's 0.2, initial layer height 0.3. Yeah, infill density 20%, and printing temperature 200 degrees. I actually the actual temperature it seems to default to is 180 degrees, but I believe it needs to be at 200 degrees. Certainly for my print bed, which I've obviously adapted this one to use the Ender 3 print bed. I'm not sure with the original print bed, because we were printing at 180 I believe before, but now I believe it needs to be 200. I'm going to leave everything else the same. Build plate adhesion, none. I'm not going to generate any supports. Now I'm just going to slice the model here. I'm just going to use the slider here on the right side to go down through the model to check the infill, and it does look perfectly sufficient for what we need it for, so that's fine. Now I'm just going to save to removable drive and export the G-code. You can see that this is the SD card here, and I'm just going to make sure we put that other file which we printed before into the prints folder on the SD card, so that there won't be any confusion between this and what we intend to print next. So I'm going to put that in the folder there. Because particularly with this particular printer, you need to make sure that there's only one file on the root directory, because you've got no way of selecting it in the menu like you would do with other 3D printers. So you have to make sure that this is the only one on the root directory. So now we're going to save that. I'll save here. Save that.
Okay, and now we're back at the printer again, and I'm just going to start it. I've put the SD card in and I'm just going to start it. I've already leveled the bed and I've raised the nozzle up so that we can just start the printing. One thing I did want to mention is that because the upper works of the printer is quite flexible, unlike most 3D printers which are actually quite rigid, I think we need to adjust the way we think about leveling the bed a bit. Because it is flexible, it means it doesn't pinch the paper in quite the way it would normally do with a rigid top works. So I think, as I say, we need to adjust how we think about leveling it. And what I was thinking was that we should release it until the paper, the resistance of the nozzle on the paper isn't felt by turning the wheels on the bed clockwise fully as possible, so that you can feel that the paper isn't being pinched, and then just release them by undoing them anti-clockwise until you just feel that the paper's being pinched. Because otherwise, I think it might lead to the bottom layers of the print being squished too much. The paper can't be pinched properly by the nozzle because the upper works aren't strong enough to actually do it. Because they're a bit flexible, the nozzle would tend to move away from the bed, even though it's quite close to it. You wouldn't necessarily know it because the top works will be deformed, or at least they'll be moved away from it. So I think, as I say, we need to rethink the idea of doing the leveling. It does require a slightly different approach, and that's what I've done in this case. So I've just done all of the adjusters up, and then for each point on the bed, I've done the adjusters up and then clockwise, so that it increases the gap between the nozzle and the bed. And then when I've got the paper underneath, I've slackened them off a bit until that very point when you can feel the paper being pinched very, very slightly. I do think that that's necessary. But anyway, the proof of the pudding is in the eating. So what I'll do now is just start the printer up, and what we'll do is just watch the first part of it. I'll Maybe I'll cut the video a little bit so you don't have to watch all of it, but we just want to watch the first few layers going down, and then after that I'll come back to it when it's finished and we'll look at the finished article to see if this approach to levelling the bed has actually worked. You can see now that the filament is just starting to come out of the nozzle. It's just starting to get to the right temperature. As I said before, it's always a good idea to watch the first layers going down, just so that you can confirm that nothing goes wrong at that stage, because that is the stage where 99% of the problems happen as it's starting to print. So you don't want to go away from the printer really until it's laid the first few layers down. Right, and here we are. The printer's actually finished, and I'm very pleased that the result is actually in good shape. I'm going to take it off, and then we'll look at it separately. Right, you can see there that the top to bottom measurement is supposed to be 15 millimeters according to the model, is actually only 13.4, so there's quite a bit missing there, 1.6 millimeters. So I'm not really sure that can be explained in any way. What we can do is to try and expand it in the Z-axis by scaling it in the slicer. Now I might have a go at doing that and see if it resolves that issue. If it's a consistent problem, which I think it may be, then I think scaling it in the Z-axis may improve it to where it is actually printing accurately. But we'll try that again. So in the X and Y axes, the hole is actually round, but it's actually smaller than it should be. It should be 16 millimeter, and it's actually around 15.2 millimeter. So it's actually a bit smaller, much more accurate in the X and Y than it is in the Z, which is good. And as I say, we might be able to compensate for these things by adjusting the sizes accordingly in the slicer, because you can adjust them asymmetrically according to the error. So I'm going to try that and see how we go. Okay, I'm going to load in the model now. I'm going to adjust the parameters as we worked out before from the error that I experienced in the size of the print, and see if it corrects for that. And so I'm just going to load up the clamp here, and I'm going to select it, and then we're going to go into the scale. So now it's showing 100% in the X-axis, 100% in the Y, and 100% in the Z. So presumably what we're going to have to do is to increase it. I said 8%, or rather 5% in the X and Y. So I'm just going to increase it to 105%. And well, it says I have to take the tick out for uniform scaling, otherwise it won't do it. So yeah, so I'm gonna have to. So that is going to X and Y do have to be 105, but Z has to be 112%. Right, okay. Hopefully that should now reflect the errors which we experienced, either the model being slightly smaller than it should have been from the X and Y proportions, and also the Z proportion, but by different amounts. So that should correct for that. And what I'll do now is to print that out again. So I'm just going to slice it. We really know all the parameters were the same from before. Nothing will have changed. Just check that it's 200 degrees printing temperature. And print speed is 40.
Also, what I might do is actually change the filament, because the printer's been outside in my garden shed for 6 months, and during that time it's been rained on multitudinous times, and it is a bit damp in there, so I'm just a bit worried that that filament might be also damp. So I'm just going to change the filament over as well, and then we'll come back to it. So now it's showing 45 minutes instead of 38 minutes before, so it hasn't added very much onto the print time. So now we'll just save that out to the SD card. I'm going to unmount the filament in the printer, because I'm going to be trying a different filament, because I think that the filament in this printer has been exposed to moisture for about 6 months. Not a direct wetness, but dampness in a damp shed. So I'm just going to unload it, and what I would suggest you do when you unload it is that you don't retract the filament, because it does give an option on the printer to retract the filament. What I'm going to say is that you feed the filament, because if you think about it, if you retract the filament, you're going to be retracting molten filament into the extruder gears, and I don't think that's a good idea. So I think it's wisest to feed the filament all the way through, as if you're going to load it, because then you won't get any molten filament in the gears. So I'm just going to do that now. So I've now set it to feed, and I've chopped the filament off above, so it should just feed all the way through until it stops coming out, and then I'll turn the feed off, and it'll cool it down again, and then we'll put the next bit of filament in. Now the filament's stopped, I've just turned it off onto cool again, and then I'll feed the next piece in. As I say, I don't think it's a good idea to retract the filament, molten filament, up into the gears when you're trying to unload it, because it doesn't make sense to me at all. You don't have to be so careful about so careful in preparing the filament for the this particular printer as you do normal printers, where you have to feed a lot of it through a Bowden tube or something like that. It's much easier to load this printer, and easier to unload it as well. It says in the instructions that you're meant to straighten apart the portion of the filament before you put it into the extruder mechanism. I tried to straighten it as best I can. So in this loading filament, we just put it onto feed, and then wait for it to warm up, and then push the filament into it. And it's now feeding through. The original black filament is coming out the bottom, and it will come out black for quite a bit, or it'll come out whatever colour you used to start with for quite a bit before it starts with the new colour. But it is starting successfully with the new colour now. It's green is extruding out. I'm turning it back into the middle position now, so that it will cool down again, as we've got a clear stream of green filament coming out of it. Just going to pull that out of the way so it doesn't dry on anything or set on anything, and it's clear green now. Now I'm just going to start the print off. Just going to turn it off at the mains again until we get our green light. Turn it on again, and you've got a steady green light now, and it's going to start the print off with a single press of the button, single quick press. Now it should start. As I say, we want to watch the print just starting. I will sort of like cut out any bits or speed up the bits so that you don't have to watch it all. I'm going to sit here and watch it all
And we'll see how it does with this filament, which has actually been in the house for the last 6 months, so it should be a lot better. It shouldn't be as damp as the other filament is. Although normally when PLA gets damp, it actually gets brittle. The other filament isn't brittle, but we don't know for certain that it isn't damp, so it could be a contributing factor. If the print quality is reduced as well, if it's a bit damp, then that could damage the print quality. And I want to try and make sure that we're properly assessing this printer's print quality rather than assessing the quality of the filament. And it's going down properly, so there's no problem with that. No problem with the first layer. So I'm going to leave it there and we'll come back to it when it's finished. Right, so now you can see it's finished and it's so much better than the other one. The surface finish is better and the dimensional accuracy is better. You can just see it from looking at it that it's symmetrical. So the fact that this is a piece of dry filament has made all the difference. Now I'm going to take the print off and we'll have a look at it in detail with the calipers and see whether it's the right size again. As you can see, the inside diameter of the hole is now 16 millimeters, of what we were aiming for, and it means my maths wasn't quite as way out as I thought it might be. So I think that's pretty much concluded for me, at least now, that if you add those compensation figures into the slicer, you should come out with a dimensionally accurate print. It looks better, the extrusion is better, but that's because of the filament, I'm sure, because I've used dry filament instead of the filament which had been in damp conditions for 6 months. I'll now go and check the other dimensions for the thickness of the print. So you can see now that the actual dimensions in the Z axis are now 15.1 or 15.2, whereas before it was quite a bit out. I believe it was 1.2 millimeters out, so it's now correct, or slightly larger than it should be, but I think that's manageable. What you could do is to adjust the compensation slightly to achieve an absolutely accurate result. Thanks for joining me, and hope you'll join me again in this 3D design and print series. Thanks for watching. Bye.